Hi, this is Judielle Angelica, our Campaner from BSRTE 2A, and we are gonna talk about Chapter 3 entitled Electromagnetic Energy. First off, we'll start by explaining photon or atom light is the smallest quantity of any type of electromagnetic energy. A photon may be pictured as a small bundle of energy, sometimes called a quantum, that travels through space at the speed of light. Next, we're gonna talk about amplitude and velocity. Velocity is the rate of change of an object's position over time or speed. And the velocity of all electromagnetic radiation is 3 times 10 to the power of 8 miles per second. It is calculated that way. While the amplitude, on the other hand, is one half of the range from crest to valley over which the sine waves varies. Next is frequency and wavelength. Frequency is the number of wavelengths that pass a point of observation per second. It is usually identified um, as cycle per second with hertz as the unit of measurement. While the wavelength is the distance from one crest to another, from one valley to another, or from any point on the sine wave to the next corresponding point. We must take note that at a given velocity, wavelength and frequency are inversely proportional. Um, it is inversely proportional. Next is the electromagnetic spectrum. It is the continuum of electromagnetic energy. Measurement of the electromagnetic spectrum contains three different scales, one of each energy, frequency, and wavelength. Because the velocity of all electromagnetic energy is constant, the wavelength and the frequency are inversely related. In here, we can see that the gamma rays, X-rays, ultraviolet light, visible light, infrared, microwaves, and radio frequency. Visible light, it is described by a physicist in terms of wavelength. When sunlight passes through a prism, it emerges not as white sunlight but as the color of the rainbow. Infrared light. It is consists of photons with wavelengths longer than those of visible light. Next is ultraviolet light. It is located in the electromagnetic spectrum between the visible light and ionizing radiation. Now we're gonna talk about the inverse square law. It is a law that states that the intensity of radiation at a location is inversely proportional to the square of its distance from the source of radiation. It is calculated by using I1 over I2 equals D2 to the power of 2 over D1 to the power of 2, where I1 is the intensity at the distance D1 from the source and I2 is the intensity at distance D2 from the source. Next is we're gonna talk about quantum theory. It is a theory in the physics of matter smaller than an atom and of electromagnetic radiation, with an equation of E equals hf, wherein E is the photon energy, and h is Planck's constant, and f is the photon frequency in hertz. Lastly, we're gonna talk about is matter and energy. Matter can neither be created nor destroyed. A law known as the law of conservation of matter states this, while the law of conservation energy states that energy can be neither created nor destroyed.